Okay, so this video is going to go over bonding. Remember, we had a periodic table. You may have to find one for you to pull up online. If you still have your pink notebook, I'd go look at your 2-7 in your pink notebook because that's where you had the periodic table that we did a lot of labeling and stuff on. But some of you have disposed of those notebooks, so that may not be an option for you. All right, so the first thing we need to remember when we get ready to do bonding is that valence electrons are very important, and so that's why we had always put these numbers 1, 2, 3, 4, 5, 6, 7, and 8 across the top. That's the same thing that these Roman numeral numbers gave us, any of those A numbers, and all that lets us know is how many electrons it has available in that outer shell in order to do bonding. And then another thing we did when we got ready to do bonds was we had to talk about ions, and so we put like the +1, the +2, and the +3. We skipped a column. We put the -3, the -2, and the -1 on top. I know some of you are thinking you just talked about that in the video that you gave us a couple of days ago that went over the periodic table, but if you remember, these units kind of had a little bit of a bridge over where some of the material was taught in both. All right, so when we had these plus things, remember we talked about cats had paws, and so those were cations. They were the positive charge. Those are the ones that are going to lose their electrons. Over here we have the negatives. Those were the anions. The anions were the ones that were going to be the gainers of electrons, and that's why they became negative, okay? All right, so I'm going to pull this off for just a second. Well, actually, no, before I do want to remind you that we have this staircase. And so what was important with the staircase is that anything that was to the left, we consider a metal, and anything to the right was considered a non-metal. When we start talking about bonding, we don't really worry too much about the metalloids. We typically just say left and right, and that's where you get to figure out whether or not it's a metal or non-metal. So you just look at that stair, that bold line that's going to be on your case, or on your periodic table, and the left's going to be your metals, and then the right's going to be the non-metal, okay? So when we started talking about the different types of bonds, there were 3 kinds of bonds. You had an ionic bond, and an ionic bond was between a metal and a non-metal. These were the ones that were going to transfer their electrons. And when they do this, you are going to do what we called the crisscross method. So, for example, the one that we used a lot of was trying to do sodium right here in the +1 column and chlorine over here in the -1 column. So what we would do is we would say that sodium was a +1, chlorine was a -1. Remember, we would crisscross, and the only thing we actually ended up moving was the number. So that was a 1, and Cl was a 1, and then we said that the ones really didn't matter, so we just wrote it NaCl to get it. And so then we had to give it a name, and so all we did was write the name of the metal, sodium, and then you write the name of the non-metal, but you change the N to ide. So instead of being sodium chlorine, it was sodium chloride, okay? Another example, let's use some that don't have just the ones. Let's do magnesium and nitrogen, okay? So magnesium was at Mg +2, and nitrogen is found in the -3 column. And so we crisscrossed it, and so we got Mg3 N2. And if we got ready to give that one a name, we would say that it was, I'm going to write it up here, magnesium nitride. Oops, didn't give myself enough space. Okay, and we'll do some more practice in a little bit. All right, so then covalent bonds. When you have a covalent bond, you're talking about putting together 2 nonmetals. These are the ones that are going to share the electrons. And just jumping back, oh, I did write that, never mind. So they're going to share their electrons. So that you don't do the charges because you don't have a plus minus. You actually, all you're doing is kind of counting how many you have. And so these are the ones that we needed to use those prefixes for. Prefixes. So if I gave you something like CO2, that's a common one that we talk about. You only have 1 carbon and 2 oxygen. So we wrote carbon, and because it was only 1, that's all you had. And then you wrote di, because that's the prefix for 2, oxide. Okay? If we had something like S2O3, that would be disulfur trioxide. Okay, and then if you were given the name of something and you had to make it into the formula, something like dihydrogen monoxide, you would say, okay, that's hydrogen, but the di means there were two, and monoxide is oxygen, and the mono part meant there was one, so you'd have H2O. Okay, and like I said, we'll do a couple more practice of these in just a minute. And then metallic was between two metals. Okay, and you just had the sea of electrons. And for this, it would be that you would just kind of write the name. It would be like nickel. It would be like gold, whatever it would be. So they're just bounded together. Okay. All right. So I have a couple of practice ones I want to hit for you. Oh, before I move too far on, remember that we didn't have anything for these transition metals that were in the middle. And so when you have those, you would have something that would have like a Roman numeral behind it. And the Roman numeral, like if it was iron 3, would mean +3. Okay, and we had done that before. All right, so let's look at a couple of these. I'm not going to do all of them. This is off of that review sheet that you had. Magnesium fluoride. So magnesium is in that +2. Fluorine was in the -1 when I looked at my column. So when I crisscross, I get Mg, and it's a 1, so I don't write it, and an F2. Okay. It was an ionic bond because it was a metal and a non-metal. Okay. All right. Let's do oxygen gas. We just said that would be O2 was a covalent bond, but it can't be singular. Oh, I don't have my polyatomics. So your polyatomics, remember those are the ones on the back of that reference guide. They tell you that they have to stay together. And so like NH4 was actually like a +1, and oxygen would have had a -2. That's how that ended up crisscrossing to get what you needed. So polyatomics, remember they're on the back of those reference guides. I'll try to upload a reference guide for you also on Google Classroom just so you have reference to those in case you've lost all your stuff. This is another ionic bond. You put the name together, it would be ammonium. That's off the back of the reference guide, and oxide. Okay, and then I'll do one more. Let's do this one down here. N2O3, it tells you that it's covalent. It's two nonmetals. I have two N's, so that's dinitrogen. And I have 3 oxygens, so it's trioxide. Okay. All right, there's going to be a Google Doc for you to go through and kind of practice with the naming and deciding what it is. You get to drag and drop the things around. If you have any questions, feel free to ask. I'll try to help you.